We've now talked about how to use the z-table to find the area under the standard normal curve, and now we're going to use that to do probabilities. And probabilities correspond exactly to the area under the curve. As an example, let's suppose we want to know the probability that z is less than negative 0.43. So if I draw my curve, we have negative 0.43 somewhere in here. And we want to know the probability that z is smaller than this number. So all the numbers to the left. Now all we need to do is move to our z-table and look up negative 0.43. Here's our z-table. Along the first column, we'll look up negative 0.4, and then move over to 3 to get 0.3336. So the probability is just 0.3336. A lot of times when you're seeing probabilities rather than areas, you'll see these written as percentages. But ultimately it can be done as either a decimal or a percentage. We're now going to try to find the area of, or the probability that z is greater than 1.82. So since we're dealing with greater than, we're going to consider these numbers to the right. So we'll start by looking up 1.82 in the table. Moving over to our table, we just need to now look up 1.82. So I go down the first row and find first column and find 1.8, and then over to the 2.9656. Moving back to the example, we had that this corresponded to 0.9656, and this corresponds to this area that's unshaded, since our table always gives this area to the left. So we need to do 1 minus this, which gives us 0.0344, or equivalently 3.44%. For the next one, we'll look at the probability that p is between 0.57 and 2.46. So 0.57 is going to be somewhere here close to the center. 2.46 is down here, and we want to find the area that it's between these two numbers, so somewhere in the middle. When we move to our table, we need to look up both of these numbers. Moving over to our table, the first number, the one to the right, was 2.46. So I'll go down to 2.4 and then over to 6, which is going to be right here, 0.9931. And that's my first value. The other one we had to look at was 0.57. So I'll go down to 0.5 and then all the way over to the 7 to get 0.7151. Moving back, 2.46 gave me 0.9931, and 0.57 gave me 0.7151, and when I subtract them, I get 0.278, or 27.8%. Now that we've talked a little bit about probability, let's talk about going the other direction. What if we know the probability? This time we actually want to find the z-value corresponding to 0.2611 to the left. So if I draw a picture, essentially what I've said is that this shaded area to the left has an area of 0.2611, and this value right here, this z-value, is what I'm looking for. So this time I know the area and not the z-value. So since we know the area is 0.2611, we have to try to find that number in the center of the table. We don't know the z-score. Instead, we know the number in the center. So we just have to look, and we can find it right here, this 0.2611. So then we're going to go out and see negative 0.6, and if we go up, we have 4. So this value is negative 0.64. This time let's find the z-value corresponding to 0.76 to the left. So this time I have Still area to the left shaded, but this now accounts for 0.76 of my area, and I still want to find the z-value. When I have my table, I now just need to find 0.76 in the center. But we'll see that this proves kind of tricky. We see right here, we have 0.758 and 0.7611, but we don't have exactly 0.76. In this case, we default to the closer of the two. 0.7611 is the closest we can get, so we have a z-score of 0.71. So moving back to our example, z would be 0.71. If we can't find the exact area, we just default to whatever's the closest. For our final example, we're going to try to find the z-value corresponding to 0.95 to the right. So essentially, I know that to the right is 95% of my area. So all of this shaded part corresponds to 0.95. However, my table does not give me area to the right, it only gives me area to the left. Since all area has to be 1, the area to the left has to be 0.05. So I'm going to look for 0.05 in my table. So here's my table, and I want to try to find 0.05. And if you look for it, once again, we can't find it exactly. It's somewhere between these two, 0.0505 and 0.0495. In my last example, I said we should default to whichever's closest. But in this case, you can see that they're both an equal distance away. In that case, the standard is to default to the middle. So these correspond to negative 1.64 and negative 1.65. So since we seem to be halfway between 1.64 and 1.65, the standard is to then default to say the z-score is 1.645.